right, in this next lesson, we're going to be writing numbers that are not written in scientific notation and writing them in scientific notation. In the example given, we have 357 times 10 to the fourth power. You can see this is not written in scientific notation because our factor is larger than 10. So the process is taking that first number, the factor, ignoring the power of 10, and just writing the factor in scientific notation. So I'm going to cover that up. And taking the number 357, writing that number in scientific notation. So we would move the decimal point in between the 3 and the 5. So 3.57, we move the decimal point 2 places, and it's a large number, so that would be a positive exponent. So that would be 3.57 times 10 to the second power. Then we bring down the original power of 10, which is 10 to the fourth power, and we use our rules of exponents. When we're multiplying numbers with the same base, we keep the base the same and we add the exponents. So we have 10 to the second power times 10 to the fourth power is 10 to the sixth power. Looking at the next example, we have 13 times 10 to the second power. 13 is greater than 10, so this number is not in scientific notation. So we take 13, we move the decimal point in between the 1 and the 3, so 1.3. I'm ignoring this original power of 10, so cover it up. 13 in scientific notation is 1.3 times 10 to the first power. We then bring down that the original power of 10, and we use our rules of exponents. Multiplying same base, we add the exponents. So our number is 1.3 times 10 to the third power. Look at our next number, 461 times 10 to the fourth power. Our number is greater than 10, so we take 461, we write that number in scientific notation. So 4.61 times 10 to the second, we bring down that original power of 10. Same base, multiplying, keep the base the same and add the exponents. So we have 4.61 times 10 to the sixth power. 98.6, larger than 10, so we have 9.86 times 10 to the first power. Bring down that original power of 10, and our answer is 9.86 times 10 to the 10th power. All right, let's flip over the page, look at the next example. So now we have a number that's smaller than 1. We need to write 0.59 in scientific notation, 0.059, excuse me. So 5.9 times 10 to the negative second power. Bring down the original power of 10. We are adding our exponents because we're multiplying by the same base, so we have 5.9 times 10 to the first power. Okay? 0.932 times 10 to the third power. Numbers less than 1, so we move that decimal point 1 place. Because we're starting out with a smaller number, our exponent is now negative, times our original power of 10, and we have 9.32 times 10 to the second power. Okay, so that's how we write other numbers in scientific notation. When we are comparing and ordering, we look at the exponents first. So here we're moving into the next example. Comparing and numbering, we have 6.4 times 10 to the third power, 5.3 times 10 to the ninth power, and 2.3 times 10 to the eighth power. So we look at our exponents first. We're ordering from least to greatest. I have 10 to the 8th and 10 to the 8th. So I have two numbers that have the same exponent. We know that 10 to the 9th power is going to be larger. From your notes, if the exponents are the same, we look at the factor, and we talked a little bit about that in class. Our exponents 10 to the 8th power, 10 to the 8th power, same, so now we look at our factor. 2.3 is less than 6.4, so we have 2.3 times 10 to the 8th power, that would be the least number. I'll cross it off. 6.4 times 10 to the 8th power would come next. And our largest number is 5.3 times 10 to the 9th power. Okay? Least to greatest. We look at our exponent first. They all have the same exponents, so we're looking at our factors. 9.02 is the least out of all three numbers, followed by 9.1, and lastly 9.6. So we would write that as 9.02 times 10 to the negative third power. That would be our least number. 9.1 times 10 to the negative third power, and 9.6 times 10 to the negative third power. Okay? In our third example, looking at your exponents, these are a little bit easier because 10 to the 7th is our smallest power of 10, followed by 10 to the 9th, and lastly 10 to the 10th. So 7.3 times 10 to the 7th would be our smallest number. 3.7 times 10 to the 9th, and 5.6 times 10 to the 10th. Okay? All right, I'm going to stop the video there and let you try the next one.